We have two workers here trying to move a 200 Newton block of ice onto a table that's 2 meters off the ground. Paula will use a ramp and Larry will lift straight up. The question is, which worker will do more work when trying to lift the block from the ground to rest on the table position? Okay, so we're going to take a look at how this ice cube block gets put onto this table. We have Paula, who's going to push the block up the ramp 6 meters, and Larry, who's going to lift the block straight up only 2 meters on our ramp at this angle theta. So each ice cube, it's an ice cube chosen so that there's no friction, right? Okay, so we can ignore that. The ice cubes start on the ground at rest, so their initial kinetic energy is 0. The final kinetic energy of the block, once they put it on the table, is also 0. So the change in kinetic energy of the block is 0. Remember earlier, we learned that the net work done by all of the forces on the box will change its kinetic energy. So here we see that the net work needs to be 0. Let's examine what are the forces that do work. So let's look at Larry's block. There is a force of gravity, mg. The block is being lifted upward. So there's work due to gravity on Larry's block. Then there's the force of Larry, pulling it upward. And that matches a positive work done by Larry. So there are two works inside the network: work due to Larry and work due to gravity. When we add those two together, they must come out as 0. So let's go ahead and examine what the work done by gravity is. It's the force, mg, and a distance, 2. That work is negative because mg is down while the displacement 2 is up. The angle between those is 180. This is negative work. It's not productive. So here we have mg, 200, negative, and a 2. Negative 400 joules. What work does Larry do? Well, these forces must be balanced because there is constant velocity pull. So here we know the Larry force that he must pull with is 200, and the distance he lifts for is 2, giving us the work due to Larry is positive 400 joules. Notice this answer, negative 400 and a positive 400, matches with our answer for D, where we notice the net work must be 0. So here, you know Larry lifted with 200 just from forces. It's a problem that we know how to do. But you would also know that the work due to gravity and the work due to Larry have to be the same amount of work, which is 400. So that 400 must equal Larry's force times the distance he applies it over 2. And you could solve for his force using the backwards work technique. We'll have to do that when it comes to Paula on the ramp, because we don't always know how to solve for the force required to push a block up a ramp. All right, let's go ahead and look at this for Paula. Paula's doing the same thing. She's pushing a block up that starts from rest and it ends at rest. The change in kinetic energy of the block is 0. So the net work done on the block is also 0. Well, what's doing the work? Paula and gravity. Let's take a look at it. Here's your block. Gravity is down, and the displacement is up the ramp 6 meters like this. So that's an overall general negative work. To get the number is a little bit more challenging. We might have to do some sort of back solving, figuring it out. Okay, work due to Paula. Paula is pushing it up like this. F pull from the Paula. And that's going to be a positive work over those 6 meters. Notice there's no kind of weird angle there. So when we find the work due to gravity, we can take the force of gravity, 200, and we can take the angle span between the 200 and the 6, which is 90 degrees to the ramp here, and the additional angle of the ramp. That's going to be the same thing as just taking the part of the 6 that's right here, the up and down part. Because remember, work can only happen in the same direction. This part is 2, and it is up. So here we can just say that the work due to gravity is the force, and then the vertical part of the motion, and that's 2. And then we realize the vertical part is up and the force is down, assigning a negative sign to it. So we have negative 400 joules of work done by gravity. Let's go backwards now for the next part. We know the net work is 0. Work due to gravity is negative 400. So the work that Paula must do is going to be positive 400 because there needs to be overall no work since there's no kinetic energy change. Cool. This will allow us to back solve and say if Paula does 400 joules of work, what force does she need to apply to move the block 6 meters? Right? And so we discover that the force she needs to apply is 66 newtons, or 400 divided by 6. So when asking who does more work, Paula or Larry, that's a trick question because they both do the same amount of work. Paula and Larry do the same work. They each do the same amount of work that gravity does, right? mgh. That's also to say, if you notice, a potential energy. The work due to gravity, that magnitude size, is always going to be equal to the magnitude change in potential energy. Both of these people did work against gravity to give the object a change in potential energy, right? And they both worked against gravity in the opposite way, negative work due to gravity. They did the same work. Now you can answer the question, who does more work and who has more force exerted? If the works are the same, that means the product of force times d is the same. Paula has less force because the ramp takes some of it, but has to push for a larger distance, while Larry lifts with a larger force, all of the weight, but lifts it for a smaller distance.